I'm Anil Kumar. On request of my subscribers, here we will learn how to solve trigonometric equations. It is also very good for students who are going to take calculus in grade 12 or in first year university. We'll solve 4 questions. These are all trigonometric equations. They involve trigonometric ratios. Question 1. 10 cos square x plus 3 sin x equals to 9, where x is between 0 to 2 pi. Secant square x plus 5 tan x minus 2 equals to 0, where x is from 0 degrees to 360 degrees. Sin 2x minus 1 over square root 2 equals to 0, where x is between 0 to 360 degrees. And cos of x by 2 equals to square root 3 over 2, where x is between 0 to 360 degrees. So most of the angles I've taken in 360 degrees. For some, they might not have done radians. It is important to note that in calculus, we always use radians as unit. And the relation between radians and degrees is something like this. 360 degrees is actually equals to 2 pi radians, right? Radians is a ratio, so normally we don't write any unit. For converting, you could also use 180 degrees is equals to pi. Now, while solving these equations, we are going to use trigonometric identities. One of them is sin square x plus cos square x equals to 1. So that will help us to write the first equation in terms of sign. It becomes a quadratic equation to solve. The second one, which we are going to use, is to work with secant square x and tan, right? So we'll see how to do that particular question. But at times we could say 1 plus tan square x is equal to secant square x, right? So that is the identity which we can use. So secant square x will be converted to tan square x. So we get a quadratic equation in tan, and then we'll work it out. In question number 3, you see sin 2x equals to something. Now you have to be careful while solving this. We are given domain for x as 0 to 360 degrees. But if the domain is changed, then you really have to write solutions. When 2x's, just multiply both by 2. So we get 0 to 720 degrees. So keep that in mind. And for the last question, purposely I've taken x by 2 to remind you that this domain should be changed, right? So for x by 2, it will be from 0 to, you have to divide by 2, right? To get x by 2, 180 degrees. Correct? So with that, I think you should be in a position to solve them. I'd like you to pause the video, solve them, and then check with my solutions. Let's begin. The very first one is kind of a quadratic equation. If I replace cos square x with 1 minus sin square x, right? So remember, we have cos square x plus sin square x equals to 1. So I could always write cos square x as equal to 1 minus sin square x, correct? So let's do that. So we'll change this 10 times. Instead of cos square x, I'm writing 1 minus sin square x. And here we have plus 3 sin x equals to 9. Now, let's open the bracket, rearrange. So we get 10 minus 10 sin square x plus 3 sin x equals to 9. Let's take all these terms to the right side. I always want to keep coefficient, leading coefficient as positive, right? So taking this side, it will be 10 sin square x. That changes sign to minus 3 sin x. This changes sign to minus 10, and that remains at positive 9 equals to 0. Effectively, we brought all these things to the right side, but wrote 0 on the right side. Okay, so that gives us 10 sin square x minus 3 sin x minus 1 equals to 0. So we are looking for product of minus 10. So you could factor this, right? So we are looking for product of minus 10. So we are looking for two numbers, P and Q, whose product is minus 10 and whose sum is minus 3. So the numbers could be 5 and 2, right? So minus 5 and plus 2. So using these two numbers, we can factor the given equation. So we'll write this as 10 sine square x split minus 3x as minus 5 sine x plus 2 sine x minus 1 equals to 0. Here we have 5 sine x as a common factor. So we have 5 sine x. And we get 2 sine x minus 1. Here we already have 2 sine x minus 1 equals to 0. So that gives you factored form now, which is 2 sine x minus 1 times 5 sine x plus 1 equals to 0. So once we have the factored form, we can always find the solution, equating each factor to 0, right? So what we are now looking for is solving these two factors. So let me just divide this page into two parts. One of them is 2 sine x minus 1 equals to 0, or sine x equals to taking 1 dividing by 2, half. The other one is 5 sine x plus 1 equals to 0. That means sine x is equals to minus 1 divided by 5. Now, when I say that sine x is negative or positive, what it means? Basically, you should remember that for solving for half, within this domain of 0 to 2 pi, that means one full circle, we get two solutions. One in quadrant 1 and the other in quadrant 2, since sine is positive in these two quadrants. Perfect. Second, for half, we can actually use a special triangle. So this special triangle is 30, 60, 90, which we can use. So this side is 1, this is 2, and this is square root of 3. Or you could use calculator in degrees. Now, radians, because we are working in radians in this case. So half for sine means that angle, which is pi by 6, correct? So we get pi by 6. The other solution should be acute angle of pi by 6, which is 5 pi by 6. Since 180 degrees is 6 pi by 6. Do you see that? So in this particular case, we get two solutions. One of them is x is equals to pi by 6. The other one is 5 pi by 6. Is that clear? Now let's find the solution for this part, which is, we can say this is sine x equals to sine inverse of 1 over 5. In fact, we'll find the acute angle alpha, right? So in this particular case, what we are going to do is, let me explain you like this. Sine is negative in these two quadrants, correct? However, we will find first the acute angle alpha, this, and then we'll know what these two angles are. This is pi plus alpha, that is 2 pi minus alpha, correct? So we will actually find alpha now. So set up this calculator to radians and now find sine inverse of 1 over 5. So sine inverse of 1 divided by 5 is equal to 0.20, let's say 0.2. So we get this angle as 0.2 as the related acute angle. So what are the values of x? So in this case, x is equal to pi plus 0.2 and 2 pi minus 0.2. Is that okay? So it is pi plus 0.2 and 2 pi minus 0.2. So those are the two solutions within the given domain. Perfect. So that is how you could do it. So I'll leave with pi itself since it makes sense. you could actually write in decimals, but that looks better. Perfect. So I'll say that the answer for the given equations is pi by 6, 5 pi by 6. These are the exact values. And then we have pi plus 0.2 and 2 pi minus 0.2. So I hope, so these are the approximate values. So I hope all this makes sense. Go through this solution once again, try to understand the concepts, and now we'll take up the second question. We need to solve the equation secant square x plus 5 tan x minus 2 equals to 0 in the domain 0 to 360 degrees. To write it in one trigonometric ratio, we could use this trigonometric identity 1 plus tan square x equals to secant square x. Correct? So I'll replace secant square x by 1 plus tan square x. So I get 1 plus tan square x plus 5 tan x minus 2 equals to 0. Let's rearrange. Rather, we can combine the two constants. So we get tan square x plus 5 tan x minus 1 equals to 0. Now to solve this, we could use quadratic formula, right? So we can say tan x is equals to minus b, which is minus 5, plus minus square root of b square, which is 25, minus 4 times ac. So a is 1 and c is minus 1, divided by twice a, which is 2. So we get minus 5 plus minus. So that is square root of 29 over 2. So let's see what this value is. So definitely x will be equals to tan inverse of all this. So we get two answers here. One is with minus 5 plus square root 29 over 2, and the other one with minus. Is it okay? So we'll now try to find both these answers. So remember one thing. Okay, let's first calculate this and then we'll work out. So let me change the mode to degrees now. Earlier we found in radians. So let's calculate this first. So what we have here is minus 5. So let me use plus first. Plus square root of 29 is equal to, and then we are dividing this by 2. And that is equal to, so there are actually two values. It's better to write these values first. We have 0.19258. The second one is minus 5 minus square root 29 divided by 2 is equal to, second one is negative 5.19258. So what you realize is that we actually get positive and negative values. For tan, as you know, well, all are positive here. Sine is positive in quadrant 2, tan in 3, and cosine in 4. So to solve for the first one, let me rewrite. That is to say, x equals to tan inverse of positive quantity, which is 0.19258. We get two solutions, one of them being in quadrant 1, the other one in 3, right? Since tan is positive in both. So we'll actually find the acute angle first. And once we find this acute angle, we can add pi to get the 180 degrees to get the other answer. Is it okay? So we'll have this. We have shift tan inverse of 0.19258 equals to 10.9. So we get 10.9 degrees here. Correct? So 10.9 is one solution. So we can say the x value is 10.9 degrees, and the other one will be 180 plus this, right? So the other one is 180 plus 10.9. Is it okay? So these are the two solutions for for case 1, right? Now let's do case 2, when x is equals to tan inverse of negative value. So if it is negative, we know that the solutions will be in quadrant 3 and 4. So let's first find the acute angle alpha. So we'll find acute angle alpha first for positive value, of course, which is 5.19258. And then we can find these two values. That is to say, we'll find later, once we know alpha, these two values, right? So this is one principal value, that is the other one. Okay, so we'll do again tan inverse of 5.19258, which is equal to 79.09. So it is, let's say, 79.1. So if it is 79.1 in quadrant 1, then what are the other two values? So the other two values are, one is, so x values will be 180 minus 79.1, right? So that gives you this one. And then 360 minus 79.1. This is the acute angle alpha. You get the idea, right? So let's calculate. So we have 180 minus 79.1, which is equal to 100.9. And the other one is 360 minus 79.1, which is 280.9. Remember, tangent has a period of pi. So you could always find the other answers by adding pi or 180 degrees. Perfect. So we have 4 solutions in this given situation also. So our answers are x is equal to these two angles, which is 10.9 degrees. When you add, you get 190.9 degrees. And this is 100.9 degrees and 280.9 degrees. Perfect. So these are the 4 solutions in the given situation. So I hope that makes sense. Let's move on and take up the next equation. Now the equation to be solved is sine 2x minus 1 over square root 2 equals to 0, where x is between 0 to 360 degrees. Now since we have sine 2x, we should actually change the domain. We are given x between 0 to 360 degrees. How about 2x? To get that, we have to multiply both by 2, right? So it's like working with inequalities. So 2x should be between 0 to 720 degrees. So that is important to begin with. Let's rearrange this equation. So we get sine 2x as equals to 1 over square root 2. Now that is a positive value. Since it is a positive value, we expect answers in two particular quadrants, quadrant 1 and in quadrant 2, right? So we expect answers here and there. Simple reason, we know all are positive here. Sine is positive in quadrant 2, tan in 3 and cosine in 4. Since we are looking for a positive value, these are the two solutions, correct? Now what can give you half? What angle can give you half? So if I sketch my special triangle, we know it is like 1 to square root 3, right? This angle being pi by 3 and this being pi by 2. I'm sorry, 1 over square root 2. So for that, we'll not sketch this one. We'll do the 45 degrees or pi by 4. So 45 degrees triangle we should have done 1 square root 2, right? So for right triangle, if this side is 45, then we get 1 over square root 2. So that clearly indicates that in quadrant 1, the angle is 45 degrees. So what is the principal angle? The other angle. 180 minus 45, correct? So that is 135 degrees, correct? So these are the two solutions which you get in 0 to 360. However, here we have 2x. So we should go one full circle extra, right? So we'll add 180 to these. So we get 2x as equal to 45 degrees, 135 degrees, and we'll add 180 to it, right? So let's add 180 to 360. 45 plus 360, one more circle, like 405 degrees. And 360 degrees will also be added to 135. That gives you 495 degrees. 495 degrees. So the value of x should be half of these. So you get 45 over 2, 135 over 2, 405 over 2, and 495 over 2. So that gives you, so 495 is already there, divided by 2 is, we get this one as 247.5. 405 divided by 2 is 202.5. 135 divided by 2 is 67.5. And 45 divided by 2 is 22.5. Is that clear? So we got all the answers in degrees. There are 4 solutions to the given equation. So I hope that makes sense. Let's move on and take up the next question, which also is the last question of this set. This time we are given domain between 0 to 360. Argument is x by 2. So we're given that x is between 0 degrees to 360 degrees, right? So what should be x by 2? So we have to divide both by half, right? So you get this as between 0 to 180 degrees. We are saying cos x by 2 is positive. That means we're looking for 2 solutions, one in quadrant 1, the other one in quadrant 4. In both these quadrants, cos is positive, right? Cos is positive. Here sine and here tan. So let's find the acute angle. So what we are given here is cos of x by 2 equals to square root 3 by 2. So we know x by 2 should be between 0 and 720 degrees. Oh, sorry, 180 degrees, I'm sorry. 180 degrees, half, right? Okay, like this. Okay, now square root 3 by 2, the special triangle, 30, 60, 90 works for us, right? So we have 1, 2, square root 3. Cos of square root 3 by 2, we're looking at this angle, which is 30 degrees, correct? So one of the solution is 30 degrees, since it is positive. So we can say x by 2 is equals to 30 degrees. And the other answer is this much. 300 degrees, which is 360 minus 30, right? 330 degrees. Okay, we calculate this because the acute angle is 30, right? So it is 360 minus 30, 330 degrees. So from here, you can write what x is, multiply by 2. So we get 60 degrees and 660 degrees, correct? So that becomes the solution for the given equation. I'm sorry, there is only one solution since we have to do only up to 180 degrees, right? We cannot take this angle, right? So there is only one solution for the given situation, which is that x should be 60 degrees, right? So our answer is x equals to 60 degrees, right? Since we know we could have taken x by 2 only in 0 to 180, right? Remember this. So I was going to forget about it. Anyway, so this is not the valid solution, right? As you could see, if I multiply 330, we get an angle which is more than 360 degrees for x. But x should be less than 360, correct? So this is not the right answer. So the only solution for this particular case is x equals to 60 degrees. I hope that makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for watching and all the best.